Hi everyone, today we're going to have a look at place value in 2 and 3 digit numbers. It's very important that we understand the value of every digit in 2 and 3 digit numbers because that will help us then to understand what numbers are made of, and it will also help us to add and subtract effectively when we come to that. So, having a look at a 2-digit number, 23. There are a number of ways that we can partition numbers, but I'm going to go through how we do it using Deans. So looking at my number 23, it's made up of tens and ones, or tens and units, whichever you prefer to use. And if I'm going to draw my number 23, I could do 2 tens like this, which are long rectangular rods, and then 3 ones. Keep my tens and my ones separate, and I'll show you why in a moment. I'm going to write my number sentence now for 23, and it's going to say 2 tens, which is 20, plus 3 ones, which is just 3, equals 23. Now, there are other ways of making 23, and what we can do is to show that we can get rid of one of these tens. So I've got rid of that one. And I'm going to move it over here. So I've still got the same amount of tens and ones, but I've just changed the order that they're in. So if we look at the left-hand side now, I have got 1 10 there, which is just going to be 10, my new number sentence. And we're now going to add the Deans that I've got on the right-hand side. So I've got 1 10 and 3 ones, which makes 13. So 10 plus 13 equals 23. So that's another way of partitioning the number 23. Having a look at these 2-digit numbers here on the next page of our slides, we can also, if we're really good at knowing our tens and ones very quickly, then we can start to use part-whole models to help us do that. So, for example, I've got 45 here. I'm just going to draw a circle around it. And exactly the same way as I partitioned using my tens and ones, I'm just going to draw a part-whole model there. And looking at the number 45, it has 5 ones and it has 4 tens. But instead of just writing the number 4, I'm going to write 40. Because 4 tens is 40. And I want to represent that. Now, if I was to partition 45 in a different way, I would draw 45 in my part-whole model again, and I might now take a 10 away from the 40, which leaves me with 30, and bring it over to my 1 side, which when I add to my 5 will give me 15. So can you see it's just different ways of adding numbers together to make the same number. So we can try that again with 45. And now if I move another 10 from that 30, I'm left with 20. And I bring it over to the 15. Now I have got 25. So can you see the pattern now that's emerging? I had 40 to start with, and 5, then 30 and 15, and then 20 and 25. Now I'm going to start that again with 64 this time. I've got my tens and ones there, and there we go. Apologies, my pen isn't the best on this whiteboard. So I've got 4 ones and I've got 6 tens, which is 60. Okay, so 60 plus 4 is 64. That would be the number sentence that would match this one. Okay, now I'm going to do that again. This time I'm going to move a 10 over to the right hand side. So now I'm going to be left with 50 here and 14 here. So my number sentence to finish that one would be 50 plus 14 is 64. And to do that one again, I am now going to look at my previous one, which I had 50 on the left hand side. Now I'm going to take 10 away from that, which leaves me with 40, and move it over to the other side, which will give me 24. It's about playing around with your tens and ones, always keeping the same amount, but just making sure that you're playing around with them and putting them in different places. Because at the end of the day, what we want you to know is how to partition numbers in different ways. And knowing that numbers are more than just made up of tens and ones, in that we have 4 tens, which is 40, and 5 ones, which is 5, which makes 45. There are other ways of doing it as well. Okay? And of course, my number sentence for this one would be 40 plus 24 is 64. Now, when we do that with 3-digit numbers, of course, it's slightly different because now you've introduced hundreds, tens, and ones. Okay? And 100 looks like a big square like this. 4 tens, 2, 3, 4, and then 5 ones. Okay? And that's 145, drawn using D's. Okay? Now, if I'm going to do that using my place value chart, my hot-hole model, I'm going to need 3 parts this time because it's a 3-digit number. Now, I'm going to start off with 100, 4 tens, which is 40, and 5 ones, which is just 5. I'm going to draw another one. Again, I'm going to keep my 3 parts, keep 100 where it is. I'm going to take a 10 out of the 40, which leaves me with 30, move it over to the 5, which gives me 15. 100 plus 30 plus 15 is 135. 45, excuse me. Okay, 100 plus 30 plus 15 is 145. Now what I'd like you to do is have a look through the numbers that I've given you, partition those into tens and ones, and see how many different ways that you can find of partitioning the numbers so that the number stays the same, but the digits that you're adding together are different.